right, section 2.3 is fairly short, but there are a couple complex ideas here. So we're going to talk about carbohydrates and lipids. So carbohydrates, the building block is called a monosaccharide. Mono means one, saccharide is sugar. So it's a single sugar that forms the building blocks of carbohydrates. Carbohydrates or monosaccharides are ring structures. I'll show you what that means in a bit. Common carbohydrates include glucose, fructose, galactose, ribose. Ribose is the one found in RNA. Glucose is the one made from photosynthesis and used up in cellular respiration, which we will talk about next unit. So a disaccharide is two sugars combined. So it's one molecule made up of two monosaccharides. So common disaccharides are sucrose, which is a combination of glucose and fructose. Sucrose is table sugar, so that's normally from sugar cane or sugar beets. Maltose is a combination of glucose and glucose, and that's found in some cereals. And then lactose, which is found in milk, that's a combination of galactose and glucose. Okay, this is the part that's a little bit confusing, but not too bad after we'll see. Monosaccharides are combined to form disaccharides in a process called condensation. So if you think of condensation like in your bathroom mirror when you take a shower, that's when water forms on top of the mirror. So when you join two monosaccharides, you lose an OH group from one molecule and an H from another. So it forms water, and that water is removed from the sugar. Large polysaccharides, so that's chains of glucose. In plants, cellulose forms long straight chains that have a high tensile strength. Cellulose is found in the cell walls of plants. Starch forms helices. Those are coils and stores extra glucose. Starch is not soluble in water, and humans cannot digest it. And in animals, glycogen stores glucose in the muscles and liver. And Google starch and glycogen can add and remove glucoses to the chains. So this picture shows you condensation when you remove water to join. So if you start at the top, you've got two sugars, and those are the ring structures that I was talking about. You've got a six-sided ring. Those are all carbons at each juncture there. So if we've got two glucoses and we take the OH from the left and the H from the right and remove H2O, water, then you join them in a glycosidic bond to form a disaccharide. And you can do another condensation reaction where you form several disaccharides to make a polysaccharide. To go in the reverse direction is called hydrolysis. So to lyse something is to split it. So you're taking water and splitting those things apart. And lipids. Triglycerides are a principal group of lipids, and that is made of 3 fatty acids and 1 glycerol. And to make those, it is also a condensation reaction, but because you have 3 fatty acids, there are 3 water molecules removed or formed. And this is used as energy storage and an insulator. Why lipids for long-term energy storage? Because lipids produce twice as much energy as carbohydrates. There is 6 times less mass because there's no water like carbohydrates have. And I bolded hydrate because carbohydrates are called hydrate, or there's hydrate in it, because they have a 2 hydrogen to 1 oxygen ratio. And that's, you get a lot of mass from all that oxygen. So if you see a large carbon polymer on a test, and if it has oxygen in a ratio of 1 to 2 hydrogens, you'll know it's a carbohydrate. If it doesn't have a lot of oxygen or any, then you'll know it's a lipid. Okay, so here we have our glycerol